Welcome to Maintaining a Balance video 15. In this video, we're going to be looking at how our body regulates salt and water, and that's through the release of two hormones that we're going to look at. And then we're going to look at how some people, if their body cannot produce those hormones, what treatments there are out them for to treat their illnesses. Here we're just outlining the role of the hormones, so we don't really need to know how they act. We just need to know what they do in our body, and then we also need to, and you're going to present a report on how we can use hormone replacement therapy in people who cannot secrete one of the specific hormones we're going to discuss. We've discussed osmoregulation before, but now that we know the structure of the nephron, we can remind ourselves that osmoregulation occurs in the distal convoluted tubules and the collecting tubules. So that's where the most water is reabsorbed, and that's due to changes in the permeability of membranes in those cells. So permeability is how easy the water passes through, and we can regulate that and change that, and that's because of some hormones. So the two hormones we're going to be discussing are aldosterone and ADH, or the antidiuretic hormone. Aldosterone stimulates the retention of salts, so we want to keep the salts in our body, and ADH stimulates water reabsorption, so that's when we want to keep water into our body. The first one is aldosterone, and this hormone is secreted when there's a decrease in the sodium ion concentration within the body. The gland that secretes that is the adrenal gland, and it increases the permeability of the nephron to sodium. So that means that more sodium is going to be reabsorbed into the kidney, and that means that there's a relatively low concentration of salt in our urine because our body is um, making sure that it is retained. ADH, on the other hand, is stimulated when there's a decrease in blood volume. It's detected by the hypothalamus, and we've looked at that part of the brain as it's responsible for thermoregulation, but the hormone itself is secreted by the pituitary gland. It increases the reabsorption of water, and that's because the distal and collecting tubules of the nephron have increased their permeability. So there's more aquaporins, which means there's more water being absorbed by the kidney tissue, which means that there's less water lost in urine as water is conserved. So we need to, as part of the dot point, address the roles that both of these hormones play. So the first is the aldosterone, and that regulates the solute concentration of the blood. So that helps to regulate the amount of sodium in particular, but also some other ions that are reabsorbed or secreted in our urine. And the other role is to regulate our blood volume. So that will determine whether our body produces dilute urine or concentrated urine, and it also determines the volumes of those of which we're going to produce. So here we can see the pathway of secretion of ADH. So here we can see, and aldosterone. So we can see that there's a stimulus. So there's a decrease in blood volume here. So that provides the information to the adrenal cortex and also to the hypothalamus. But also we can see down here that we can see an increase in blood volume here. So we can see again that seesaw effect. There are some patients that must undergo hormone replacement therapy as their bodies cannot produce the correct amount or um, the and at all even the right hormones for their body. So it means as opposed to producing the hormone naturally, they must be given it to them artificially. So the dot point tells us that we need to investigate what happens when there's a aldosterone deficiency. So the disease which results from aldosterone deficiency is called Addison's disease, and sometimes it's because the adrenal glands can't produce the hormone. Sometimes it's due to an accident or disease. Sometimes the pituitary gland um, doesn't isn't able to send the message to the adrenal gland for production. Because of that, it can result in low sodium levels in the body. which means that there can be an imbalance which can produce different symptoms. So sometimes it's just weakness and fatigue. Other times, due to the imbalance, it can mean that the blood pH changes, and sometimes it can cause heart failure, which means that a person would have to go to emergency and get the salt and water given to them other ways, and given the hormone as quickly as possible to make sure that it rectifies the situation. This dot point is going to be investigated more by you in class, so you'll have to complete the activities on Google Classroom. Thank you for watching video 15. We're very close to finishing the end, but make sure you tune in for video 16.